Dear students, see the next one from Neet question. It is from 12th standard semiconducting device based question. So in this question, this is one of the match the following type question. So here, side A, we can say the left side and right side, like one tabulation is given. In this tabulation, A, B, C, like that, 3 graph is given. Then right side, A, B, C over, then D, E, F and E, like 4 components name is given, like solar cell, light emitting diode, photodiode and xenon diode. So now we want to match the graph with the concerned device. Okay, so how? We'll discuss one by one. See that if you observe this graph, it is x-axis voltage, y-axis is represent the current, as well as here something is given I1 and I2 and I3, that is known as intensity of the light. Okay, so here which device is related with the intensity of light? Okay, then here there is some relationship between light as well as current. See that it is intensity that is related with light. Here the current is changing, so there is a relationship between that is light and current. So which device is related with that? Maybe the solar cell and then photodiode. Okay, அப்போ அது ரெண்டில் ஏதாவது ஒன்றா தான் இருக்கும். Okay, right. So now I want to tell one thing. Here, if you focus, this is that is a reverse bias. So biasing, so that is a keyword. So in this operating in reverse bias. So among the solar cell and photodiodes, so here the reverse bias you know very well, that is photodiode only related with the reverse bias. So just I recapitulate that. So please listen. We know that it is that diode. So in this diode, you know that P region and N region. But in the photodiode, in the center part, here one transparent window is there. So in that transparent window, the light will be falling on the diode. After that, here electron and holes pair will be generated. So in this situation, we can connect it as a reversely. That means positive region connected with the negative region connected with the positive. So here positive, here negative. This is reverse bias condition. In this reverse bias condition, here electrons holes will be generated. So here that holes is moves towards to the negative terminal of the battery, as well as electrons is moves towards to the positive terminal of the battery. So this is operated by the reverse bias. As well as one more idea, if the light intensity is increasing, that photo current also won't happen, it will be increasing. So here it should be I1, I2, I3 is nothing but intensity of light. So here we can say intensity of light 3 is greater than intensity of light 2. Intensity of light 2 is greater than intensity of light 1. So when the light intensity is increasing, as well as reverse current also increasing, so this is purely depends upon photodiode. So A is F. A is F means immediately we can say here option A only, the first option is suitable. So A is F. Okay, so exactly option A only correct. But anyhow, we'll be discussing about the second graph. Okay, right. So let's see that second graph. Please listen. The second graph, it is in that forward bias. Okay, forward bias. So so already photodiode is over. Okay, maybe here the solar cell LED already over. Sorry, LED is there. Okay, then xenon diode. So very well xenon diode. It is operating in reverse bias. அப்போ கண்டிப்பாக இது வரவே வராது. So you forget this. So whether light emitting diode or solar cell. So just you see that light emitting diode. So that is electricity is converted into electrical energy converted into light energy. But in the photodiode, light energy converted into electrical energy. Okay, light energy increasing, current is increasing. That is photodiode. But now let's see the forward bias. See that maybe I think LED. Let's check. So light emitting diode also like photodiode. Here positive region, entry negative region. Here transparent windows there. But it should be connected with the forward bias. So forward bias means negative terminal, negative region connected with the negative terminal, positive region connected with the positive terminal. So here in that P region, that majority, mostly we know that here the holes are there, in the N region electrons are there. So here it is in that forward bias. Due to the forward bias, this positive terminal to repel the holes, so it will be moving opposite side, as well as this negative terminal, okay, to repel these electrons, so it is moving opposite to the holes. So here the collisions will be happen. So due to that, heat with the light is generated, so it will be coming out. So that is light emitting diode. So this symbol light emitting diode. This is diode. This is xenon diode. Now that this is light emitting diode. For photodiode, photodiode. So this is photodiode. Input is light energy, that is photodiode. Output is light energy, that is light emitting diode. So we know that it is purely, what is that? Forward bias. So the forward bias. So there is a combination of forward bias. So it will be, answer is what? Light emitting diode. So B is E. For B is E, light emitting diode. So this is also over. Next, remaining one. Okay, remaining one what? That is the solar cell. Anyhow, I will explain that solar cell. So please listen. So if you observe in the solar cell, this is like a photodiode. Photodiode, photodiode light energy converted into what? Electrical energy. Like that, here that source is what? The solar energy. Okay, so in that light emitting diode, initially, okay, for example, here there is some region is there. Okay, so in the upper part or down part like that, one diagram is there. So here P region or N region, here the electron P region, there is a holes, so it will be connected with the what? This is connected with the external resistance. Okay, that is like a load resistance, or the circuit becomes shorted. Okay, so when the light energy is falling on that, it gets the energy. Okay, so after that it will be overcome this region. Okay, so here due to that overcome the region, so it will be recombined, so we can get the current value. Okay, but here we discussed, so I didn't explain the full theory of solar cell now. Okay, so I'm going to focus only the graph now. Okay, so this is that without resistance, this is open circuit. With the resistance, this is short circuit. So that only I'll take here, because here in this graph they mention as open circuit and the short circuit. Okay, so just to open circuit it what happened? Okay, so it is an open circuit. So in the solar cell, it is the open circuit. So in the open circuit, it will be generally receive the energy, okay, but there is no current in the output, but full voltage is there. Okay, so if you observe this graph, it is the voltage, then this is current in y-axis. Okay, so initially in open circuit, okay, the full voltages are there, but no current. So that only we mention as here open circuit. Okay, but it will be shorted. That means that external resistance is connected, we can get the output from the cell. So that means short circuited. So here the gradually, so what happened? When the current value increasing as well as voltage value reducing. Okay. So now we can say that the current value increasing as well as voltage value reducing. Current value increasing, voltage value reducing. So we can get here this point. So this point is called as, this is like what? Short circuit. Okay. So if you observe that solar cell, without connecting that external voltage, it has full voltage level, full potential. After connecting that external resistance, okay, that voltage value is gradually reducing as well as the current value is increasing. Okay, so this is satisfied with this graph. So on graph C, that answer is what? Solar cell, that is D. Okay, so now first graph F, that is photodiode. Second graph, that is E, what is that? Light emitting diode. Third graph, that is solar cell. That's why. Okay, I hope you understand. Okay, based on the graphical explanation alone. Okay.